Okay, in this short video, what I'd like to do is basically go through and show you how to find the gene sequence for your assigned heme synthesis gene. And what we're going to do is we're just basically going to pull up the Word document on our computer. You'll notice when you're in Word, if you hover over any particular link, it will oftentimes give you information about it. And so what we're going to start is just start by we want to go to a particular genomic entry within the gene bank, and this particular entry is one that will best match the strain that we're going to be cloning from, which is E. coli BL21 DE3 strain. And for this demonstration, basically the particular genomic sequence that we're going to go for is the CP001509. So if we hit Control click, it will open our browser window and it will open a tab on that sequence, and it should look something like this. And you'll notice at the top it'll say nucleotide. In a particular, to get this link, I basically went to pubmed.org and I did a nucleotide search, and I was searching for E. coli genome, but particular E. coli with this BL21DE3. Now, if you just were to scroll down, you'd see, well, the genes are listed, and so they have different names. Like here's a THRL. This is probably a gene that's involved in potentially the synthesis of threonine. That's my guess. I don't know for sure, but you'd have to kind of research these names and whatnot. But we already know the gene name because that is what I'm going to give to you. So in your assigned, let's say you're assigned heme B. Now, how would you find it within this document? Well, what I would do is I would just hit Control F. Control F will pull down a search window in your browser, and then you can type in heme B. And if I do that, you can see there's one of three that were found. And basically, if I look down in the document, within Chrome, it's already scrolled me down. I'm doing this within Chrome. It already scrolls me down to the heme B gene. Now, if I click on heme B, I can come over here and click on the gene. If I click on that and I look down at the bottom, it gives me this warning message. It says you have to basically cannot highlight the feature because no sequence is shown. So you just click on show the sequence. When you do that, it takes it just a few minutes to download. The sequence is about 16.8 megabytes. So it takes about 20-30 seconds. You just patiently wait and it will download. You can see the progress down here of downloading the sequence. When it does, it will go directly to your heme B sequence or whatever gene you've clicked on. There we go. See, and it highlights it here. Now, I don't want all these line numbers, and really what I want to do is I want to show you there's two forms of this we can look at. You look down here in the browser window, there's a little button labeled GenBank. We're going to click on that. That will take us to the GenBank entry for our heme B gene. Now, you notice here, it's the region that goes from the base number 354,640 to 355,614. So our gene is about 1,000 base pairs. Actually, if you look at the GenBank entry, it's 975 base pairs, because even though it says this is the complete genome, that's for this, but we're looking at a particular region of that. And if you look down, you'll see here within features that we're looking at heme B gene. The gene is heme B. Now, notice here it says the complement. You're going to see something as we look down at the sequence. Now, there are a couple of things in this feature block that are interesting to note. One, you get the name of the enzyme. So the aminolevulinic acid dehydratase is listed right here. You actually already have the translated sequence listed here as well. But then down here you have the DNA sequence. But you'll notice this starts with TTA, not ATG. What's up with that? Well, if you look down at the end, and you were to look at this, you say, well, wait a minute, this is, if going backwards, it is TAC. Well, what would be the complement of this? Well, going in the reverse direction, the complement of this would be ATG. So what you see here is you've got the complement of our gene sequence. So what we'll need to do, and I'll demonstrate this with this sequence, we'll need to do is we will need to generate the reverse complement of this sequence in order to work with it. But for starting purposes, I'm just going to highlight this GenBank entry for our heme B. We'll just highlight it. We'll do Control C, or just right-click Copy. And then I'm going to go to a blank Word document. And within Word, if you paste, you want to be careful. There are different ways to paste. And so you can either click up here and look at the different options. What I want to do is basically, I just want to paste. I don't want to paste with any formatting. I'm sorry. I don't want to paste with merge formatting or this. I'm actually going to just go ahead and keep our source formatting in this instance, because I can see that that's going to, that looks about right, about like what I want. So basically, actually, I'll tell you what, let's just go with, no, I think the spaces are going to be in there regardless. So let's just go with this. We'll leave that in, and that gives us basically more or less the format. Sometimes if things are, you know, like look like they're overlapping, you could change the font size. If things look like they're too broad, wide, you could change the font size down to like 8 or 9 or something like that, and then that basically keeps it all with it. So you could format it. It's really just for you to have the information in a format that you can read. So now I've got this. I'm actually going to go up to the top of my document and just remind myself that this is GenBank entry for heme B. And that's what we have here. Now, I want one of the things that is going to be more useful for me to work with is actually the FASTA. So I'm going to go back. We'll just put it in here. We'll do the FASTA. It's actually capital. FASTA for heme B. And we're going to paste that in down here. So how do I get that? Well, if I come back to my GenBank in my browser, I could just click on this up here. It says FASTA. When I do, I wait just a little bit. What it's going to do is it will go and it will fetch just the FASTA entry. And so if I take this and I highlight it just up to here, that gives me, and I do a copy, that will give me the FASTA entry for my gene. And I can go back to my document. I can paste it in here. Now, one thing I'm going to caution you on is that it's oftentimes useful to just go ahead and take out these end-of-line returns, because you get them when you paste, you copy and paste from the browser. I'm just going down, I'm just deleting the end-of-line. There are other easy ways to do it, but I don't want to go into that. So I'm just going to show you the kind of brute force method here. And so that gives us our FASTA, where all of this is now in one line, and then this is in one line. So basically the header line, and then this would be the sequence line right here. Oh, it looks like I didn't get this one here. So I will, did you see what you might not have seen that, so let me just demonstrate that again. You see how I have this other little thing here? That looks like a space or a line return. So I'm going to delete that, that little bump, and it's gone. And so now I have it all as one line. Now, you'll notice this is the sequence directly from our gene sequence. Now, this was sequenced in a particular direction, and so what this means is that this is being read in the opposite from the way the sequence has been determined. Now, this is not unusual, because basically within the genomic sequence, not all the sequences are pointing in the same direction, and so that's just important to be aware of. Basically, heme B is in our genomic sequence is basically in the opposite direction of the way the sequence was generated. Some things are going to be in the forward, some things are going to be in the opposite. This happens to be in the opposite. But if you've got one that's in the opposite, what do you do with it? Now, I am going to, because we really don't need this particular header, I'm going to simplify that And we're just going to call this heme B, because that's really all we need. I think I'm just going to put a couple of carriage returns here to get this all on the same page. And we have our, basically our DNA sequence for our heme B, but it's in the reverse direction. So we want it in the forward direction to be able to design our PCR primers. So if you go, there are a couple ways to do this. Let me demonstrate to you by going to our Blackboard site. And on Blackboard site, I'm going to have a link under, it won't be under experiment 1, it is going to be under our content link. Let me get back to, we'll just go to content, and under contents there's a link directory, and under link you can go to this link here that's generate the reverse complement. So that'll take me to this website. Now what I want to do is go back to my blank document, and I want to just highlight the text. Whoops, I want to make sure I include everything though. Include all of your nucleotides, and then I want to just copy that. And then I'm going to come back to my browser window, and you can paste the raw sequence or the FASTA sequence. I'm just pasting the raw in here, and I want to tell it to generate the reverse complement. Now, you have to be careful, because if you just generate the reverse, it's just going to generate the reverse of the sequence you submit. If you generate the complement, it will just generate the complement of what you submit. You want the reverse complement, and then you say submit. Okay, so here's our results. We could click it on anywhere inside this window and do Control-A to select all, and then Control-C to select copy, but you can also do that with the right click. You could do select all, or you can do copy here. So we've done copy. We're going to come back to our blank document. We're going to come down here, and we'll do heme B, and we'll just do a new line, paste our sequence in there. Actually, what we can do is come back up to this one, and we'll modify that FASTA header line and label this as the reverse complement, so that we know what we have. Now, down here, we have our heme B sequence. You can see here's our start codon, ATG. You can see here's our stop codon, TAA. And I'm actually going to demonstrate one further thing, because I think it's just useful to see. We're going to now take this sequence. We don't actually need the header line, so let's just take the reverse complemented sequence. We copy that. Actually, it's already in our clipboard, but if we've done something else in between, we need to copy it again. And then we're going to come back to our Blackboard site, our links, and we can go to this translate link. This is basically Xpasi. Xpasi.org has a translate site, and we can paste, Control-V, paste, and I'm going to go with the output format of verbose. And with the verbose, we actually will get to see both our, we also want to include our nucleotide sequence. So I'm going to do include nucleotide sequence, and then we'll go translate the sequence. Now, what you'll see is you'll see multiple frames. Because we're just translating only the gene sequence, we should be in first frame. So here you see the ATG corresponds to the methionine. And then if you look throughout the sequence, you'll see no stop codons until you get down to here. And then you would have your stop codons. So this basically gives you the nucleotide sequence and the amino acid sequence for your heme B. Now you can select this. You don't actually need that frame 1 part, so we'll just select it up to here. Copy that. Go back down to your blank document, and then this becomes your working document. Whoops, didn't mean to do that. Let's put it here at the end, and we'll paste that in. This then becomes our working document for our heme B. This would be our translated heme B sequence. And then if we come back up here, we've got our GenBank entry. And basically this, if you wanted to, you could then just title this as your heme B working document. And that basically gives you a place to keep your notes and store things electronically if you want to come back and reference this at any point. So you could just save that. I oftentimes will even make that a title and center it. So there you go. Now you have your DNA sequence. This is the most important part. This is what you're going to copy your bases from the beginning and copy your bases from for the end to do your primer design. So now as you go on through Experiment 1 handout, you can use these sequences for your primer design.